So a couple things to remember while you're getting started with these angles. Number one, remember that the three angles of a triangle always add up to 180. You're going to need that sometimes in the middle of a problem, sometimes at the end. But we want to make sure that we can always go back and figure out missing angles. And then we got to remember that corresponding angles of similar figures are congruent to each other. And corresponding angles mean that the letters line up. Oops, line up. That's L-I-N-U, line up. And I'm going to show you in a second. I'm going to show you what I mean by that. So then it says, make sure you line up the letters so you know what are the corresponding angles, because the diagrams can be deceiving. So that means, like, I don't have an example here, but if it said like triangle XPQ is similar to triangle ZWV, I like to take the letters and write them underneath each other just like this, ZWV. And then what that means is that the angle at X is the same as the angle at Z. The angle at P is the same as the angle at W. And the angle at Q is the same as the angle at P. And that helps me make sure that the diagrams, sometimes the diagram doesn't have to be set exactly the same way. So you use this. I like to kind of number the angles or something. When we get into the sides, we'll do something different with lining letters up, but this is super important. And the bottom line is, you're going to see problems where it throws the scale factor in. Don't use the scale factor for angles. It has nothing to do with angles. All right, the scale factor is for sides and then later on perimeter and area. But if you start taking the scale factor and using it in terms of the angles, it's going to get your answer's going to be wrong, because the angles don't change in similar figures, just the sides do with that scale factor.